Hey, welcome. Today we're going to take a pretty incredible journey deep into the Earth's crust. Why? Because we're going to uncover the hidden materials that literally power our modern world. Everything from the giant skyscrapers in our cities to the smartphones we're all holding in our hands. So let me start by asking you a question. I want you to think about three totally different things: the phone you're probably watching this on, the toothpaste you used this morning, and, yeah, the actual bones inside your body. What in the world could connect all three of those? The answer is actually super simple: minerals. They are an absolutely indispensable part of our lives, and they are literally all around us. I mean, from a tiny pin holding some fabric together to a massive cargo ship crossing the ocean, everything is either built from minerals or with minerals. They're in our food, our homes, our tech, you name it. So, what exactly are these things, these fundamental building blocks of our entire planet? Let's start right there. Okay, so the official definition is a homogeneous, naturally occurring substance with a definable internal structure. Sounds a bit dense, right? Let's break it down. Homogeneous just means it has the same chemical makeup all the way through. It's pure stuff. They form in nature, not in some lab. And they have this unique, repeating atomic structure, like a perfect crystal lattice that scientists can actually map out. We find them inside rocks as raw ore, which we then have to process to get the pure mineral we can actually use. Now, minerals don't just pop up randomly. They have different, let's call them, modes of occurrence. You can kind of think of it like your friends. One might always be at the library, another's always at the gym. Minerals are like that. Some show up in cracks inside big rocks. We call those veins. Others form in these really deep layers, like coal. Some are just what's left over after a rock has been weathered away for ages. That's how we get bauxite, the source of all our aluminum. And believe it or not, some, like gold, are even found washed down into valleys or just dissolved in the ocean itself. Now get this. When we look at all the metallic minerals we pull out of the earth, one single category makes up a whopping 3/4 of the entire total. And that's 75%. It all comes from what we call ferrous minerals. That's just a fancy term for any mineral that contains iron. They are without a doubt the absolute backbone of our industrial world. They provide the strength for basically everything from skyscrapers to cars. Okay, so iron is a huge deal. We get that. But how do we get from that raw ore stuck in the ground to the steel and other materials that actually build our world? Let's take a look at how it's classified and used. In the world of iron ore, there are really two main stars of the show. First, you've got magnetite. This is the high-grade stuff, with about 70% iron content and, as the name suggests, fantastic magnetic properties. But the real workhorse, the one that does most of the heavy lifting for us, is hematite. Even though it has a little less iron in it, it's by far the most important iron ore for industrial use all across the globe. All right, let's shift gears. We've talked about the materials that build our world. Now let's talk about the energy that powers it. For centuries, that power has come from these conventional sources, buried deep underground. We're talking about fossil fuels. And just like with iron ore, not all coal is created equal. Nope, it comes in 4 distinct grades, all based on quality. Way down at the bottom, you've got peat. It's got low carbon, tons of moisture, so it doesn't give off much heat. A step up is lignite, but it's still pretty low grade. Then you have bituminous. This is the most common commercial-grade coal, the kind used all the time in power plants. And at the very top of the pyramid is anthracite, the highest quality, hardest coal you can find. The other major fossil fuels, petroleum and natural gas, have this really fascinating origin story. See, they're formed from ancient organic stuff that got trapped in these folds of rock deep, deep underground. They get stuck between layers they just can't seep through. And because natural gas is lighter than oil, it often ends up collecting in a pocket right on top of the petroleum deposit. But as we all know, the age of fossil fuels has its limits, and it definitely has its consequences. And that leads us to a really critical turning point in our whole energy story: the shift towards a renewable revolution. And I mean, the difference between these two eras, it's stark. It's night and day. Conventional sources rely on fossil fuels that will eventually run out, and they create a really heavy environmental impact. Non-conventional sources, on the other hand, tap into renewable elements like the sun and the wind, offering a path forward that's so much cleaner and way more sustainable. And just look at the incredible variety of options we have in this new era. We can harness nuclear energy from atoms, solar energy from the sun, power from the wind.
biogas from organic waste, tidal energy from the oceans, and even geothermal heat from the Earth itself. It's a whole portfolio of cleaner solutions right at our fingertips.
So, this brings us to the final and, maybe the most important part of our journey today. Once you understand where our resources come from, it forces you to confront the consequences of using them and the absolutely vital need to conserve them. The whole process of extraction has these hidden costs. For the miners, the constant breathing in of dust and fumes can lead to devastating, lifelong lung diseases. For the environment, waste from mining contaminates our water sources, and the process itself just degrades the land, leading to pollution and soil instability. It's a heavy price to pay. I want you to really think about this staggering fact. Minerals make up just 1% of the Earth's crust. 1%. And yet we are consuming these finite resources that take literally millions of years to form, at a pace that is completely and totally unsustainable. So what can we do? Is it hopeless? Not at all. The path forward really involves a three-pronged approach. First, we have to use technology to get smarter, to be more efficient and way less wasteful when we extract minerals. Second, we have got to get serious about recycling metals and using scrap. And third, we need to actively choose renewable alternatives and find substitutes wherever we possibly can to reduce our dependence on digging up new materials. Let's end on a really powerful idea. We often think about conservation as just using less, right? Like it's a sacrifice. But what if we reframe that? Every single bit of energy we save is, in effect, energy that we have just produced. It's a simple thought, but it has some pretty profound implications. So the final question isn't about what you'll give up. It's this: what will you produce today, simply by saving?